Hi everybody, in this video I will show you the solutions to the long test you took on Friday the 21st of October. I will also provide a video for how to use the calculator for certain of these questions. Please feel free to pause the video or skip forward as you see necessary. In addition, I will upload the PDF to this video. Use this video as much as you can to help you improve on the questions that you saw in this test, which is all about analysis and in particular functions of differentiation and other types such as finding the parity and all that. These are all very important things that will come up again and again, not just in 6th year, but in the back as well. So let's start. Question 1. State the domain and range of the following functions. Now, highlight what the question wants, the domain and the range. Now we can plot the functions using our calculator, but there's no restriction. There's nothing here that says, oh yeah, restricting, like, you know, x is, I don't know, some sort of restriction. So for question 1a, if it's a polynomial order 1, you should know that the range and the domain will always be, as long as it's not restricted, all real values. For b, it's x squared minus 6. Now, you should be able to, if you did a quick sketch on the calculator, plot on the calculator, it's going to do this, where you know that point there, well, I thought it said plus 6, so let's just go back. Well, that point there is minus 6. So the x can be all values, but the y has to be values where y is greater than, but it also can be equal to minus 6. And finally, for c, we have f of x is equal to x squared minus 8x plus 2. So I'm going to use the calculator. I'm going to make sure I'm in a new document. Every page is going to be, every question is going to have a new problem. So I'm going to plot my graph on my calculator. So x squared minus 8x plus 2. And I need to just zoom out. So menu 4 for Windows zoom, zoom out, and I'm just going to try and find the minimum point on the graph. I push escape. I'm going to do a video for what I'm doing on the calculator here shortly. Menu, analyze graph, find that minimum value, and I go left of the minimum, right, and I find that it happens at the minimum value is when y is equal to minus 14, but x can take all values, so x is all values, and y, we can have y is all values, but it has to be greater than or equal to minus 14. Look at it, says you can use your calculator in any way for this question. I could have completed the square. So this is, if I was to complete the square, it would have become x minus 4 squared minus 4, because that's the minus 4 from inside the bracket, add 2. So I get x minus 4 squared minus 16 plus 2, so x minus 4 all squared minus 14, and this minus 14 links with that 14. We have 2 marks for each of these questions, and you see there's the 2, 2 and 2. So now to question 2. Determine the parity of the following functions. State whether they are odd, even, or neither. So we'll just say it's the parity I'm looking for. So for a, f of x is equal to 4x minus 2. So I put in the minus x into it. Every time there's an x, I replace it with minus x. So I get minus 4x minus 2. Now, this is not equal to f of x, and it is not equal to minus f of x. So this function is neither. If you did a plot on the calculator, you'll see it's going to look something, slip slightly like that, and this is not an odd or even function, so it's neither. Part B, f of x is equal to x squared plus 4. Now I know this is an even function, it's going to do something like this, but I said I'll argue it algebraically. An algebraic method must be seen. So f minus x is equal to minus x squared plus 4. When minus x is squared, I get that. And then I must state is equal to f of x, and therefore even. And finally c, don't have much space for doing c, 2x cubed plus 5x squared. I put in there. Minus x cubed is minus x cubed, so minus 2x cubed becomes that, minus 5x. Then I'm going to factorize the minus out of it, so 2x cubed plus 5x, and you can see that it's going to be f of minus of x is equal to minus f of x, which is therefore odd. Okay, and again we're looking at 2 marks, 2 marks, 2 marks, and if you're looking at the timings, we're looking at 36 marks for 40 minutes. So if you're spending a mark a minute, that's going to be perfect for you. So consider the function f of x equals x squared plus 3x minus 5. Describe fully in words the transformation that would result by that. So we have, it is a translation by, we can do it like this actually, 2 right and then 3 up, or we could write it as, we could actually say or a translation by 2 units in the positive x direction and by 3 units in the positive y direction. There's 2 transformations there, translations even, sorry. That's why you had 2 marks. Show algebraically the new function in the form of that. So we know that g of x is equal to f of x minus 2 plus 3. So we know what f of x is. F of x is equal to x squared plus 3x minus 5. So I just need to replace, every time I see an x, I replace it by this x minus 2. Notice how, let's just change the colour. That there, it's gone in there, gone in there. And then, oops, go back to blue. I've got that minus 5, and then at the very end I'm adding 3 to everything. I'll show you how to do this in the calculator as well. Expand all of that, I get x squared minus 4x plus 4 plus 3x minus 6 minus 5, and don't forget to add the 3. Collect like terms, I get x squared minus x, 4 minus 6 is minus 2, minus 2 minus 5 is minus 7, minus 7 add 3 is minus 4. Let me just add a new page. And for part C, it says sketch them. Now I find it difficult to sketch, to draw straight lines on my iPad. But it says sketch both of them. Now I'm going to use my calculator here. New question, so new problem. Doc, insert, problem. I'm going to insert a graph, and I'm going to insert both of these functions. So it was x squared plus 3x minus 5. And I can put it into my calculator in 2 ways to do this one. I'll show you how to do this. So I'm just going to say f1 open brackets x minus 2 plus 3. I could have also just put in what I got for part B. It would be exactly the same thing. So I have, first thing is there, and the second one is, now what information did I want on it? Label any axis intercepts. So all I wanted was the axis intercepts. So I just want to have the following points: that point, that point, that point, that point, and that point, and that last one. So menu, analyze graph. We can find for intersections and all of that. Okay, I'll show you the easiest way actually to do it is through menu, geometry, points and lines, point on, and highlight the functions. Okay, minus 4.19. I'm going to show you how to do this on the calculator. It's really quite easy. The next one is minus 1.56. That's 1.19. And then we've got one more x-axis intercept, 2.56, and then I've got to do the two y-axis. That's minus 4, and that one there is at, well, we can do it from the graph quite easily. It's minus 5. Just want to check something with the graph I've made. Yeah, that's fine. Absolutely fine. Okay. And that's that done. And that was worth 4 points. Now on to question 5. Question 5 already? I think we might have missed a question out. That's question 3. 2. Have I missed out question 4? I might have to go back to question 4. Okay, I'll come back to question 4. Don't worry, I'll do question 4 at the end. So question 5. For the following questions, find the derivative function, the coordinates of the turning points, and the nature of the turning points. Show key working steps. So we've done quite a lot of these now. So the derivative is 2x plus 6. The coordinates of the turning point is 0 is equal to 2x plus 6. So take away 6 from both sides. Divide by 2. Now I want the coordinate point. So I put into my function the number minus 3. That becomes minus 3 squared plus 6 minus 3 plus 5, which is equal to 9 minus 18 plus 5. 9 take away 18 is minus 9. Minus 9 add 5 is minus 4. I'm going to show you how to do all of this on the calculator. So that's minus 3 comma minus 4, and we have to determine the nature of the turning point. So I have to do the second derivative, which is equal to 2, which is, this is greater than 0, so therefore we have a minimum. Do the same for part B. So y is equal to x cubed minus 5x squared plus 2x minus 1. So we differentiate it, so dy by dx. Notice I don't say equals, I just go straight to dy by dx. So that's 3x squared minus 10x plus 2. I let this equal 0 and I solve, and I'm going to use the calculator to solve this to make it a lot easier for me. So insert a new problem. Calculator, I'm going to do solve, open brackets, 3x squared minus 10x plus 2 equals 0, comma x. And it's given me some lovely numbers here. So I could use the exact, but I'm going to round it. So x is equal to 0.2137, or x is equal to 3.11963. Substitute that back into y. What I'm going to do is I'm going to use the graph page. Again, I'll show you how to do this on the calculator as well. But in my function, okay, that's defined, and then I just go to, I need to zoom out because it's slightly zoomed in too much, so zoom out, and I just do menu, analyze graph, minimum, either side of the minimum value, so I get 3.12 comma minus 13.1, it's all rounded, and the other point was the maximum value. So analyze graph, put the maximum lower and then upper, and I get 0.214 comma minus 0.791. We need to determine the nature of the nature of the turning points. So part C, I'm going to differentiate this again. So I'm going to do d2y by dx squared is equal to 6x minus 10. I differentiate the dy by dx thing again, and then I substitute my values of x in. Now, I think it should be pretty obvious. When I do this, when I put 6.2137 take away 10, this is going to be less than 0, because 6 minus 10 is minus 4, but 6 times 0.2 is going to be even less than 6. So therefore, this is a max. And when I put 6 lots of 3.12 in here and take away 10, well, 6 times 3 is 18, so it's going to be a positive value, so therefore min. Give me all the points. That's 5 points for both to get all, so it's 5 and 5. And I'll show you how to use the calculator to get loads of marks on this. Question 6. Consider the function y is equal to 4x squared plus 5x minus 2 to determine the x values to which the function is increasing. So you may use the calculator in any way you wish. So I'm just going to add a new problem. So insert problem. Plot the function on the graph page. So 4x squared plus 5x minus 2. And then all I'm going to do is find the menu, analyze graph, minimum value, go left of the minimum, right of the minimum. I can see that the min is at x equals minus 0.625, therefore increasing when x is greater than minus 0.625. Just a very quick sketch. It looks something like this, and it's increasing for this part here. Okay, that was only meant to be a very quick question. The next one is question 7. Consider the function y equals 5x squared minus 4x plus 2 to determine the gradient of the function at minus x equals minus 3. So I differentiate it. Equals to 10x minus 4. I put the value of minus 3 into it, so I go 10 lots of minus 3 minus 4, which is equal to minus 30 minus 4, which is equal to minus 34. And that's it. 2 marks. They shouldn't be taking you long, these questions. Question number 8. By showing full work and calculate the inverse function of f of x. So I let y equal 3x minus 2. I then rearrange, so I do add 2 to both sides. Now I divide by 3. And now I replace the x and the y's. And the final bit is to, and that I have worth 3 marks. And we should be absolutely fine with manipulating equations like that.